bending moment or deflection. So sometimes you have to choose maybe most optimized sizes. So we are very close, right? See that? 0.987, 0.999. So these two members, but obviously stiffness wise, 24 by 55 is much stiffer than 21 by 55, even though same materials, pound per foot. So 3.727. But I don't know why, but that's a good point. That's why at the first run of few iterations, if you're interested, let's run it. And as a structural engineer, we should group it. Let's run it first. Still, we have some differ. Let's we analyze it and iterate one or two times because we changed the design criteria. So I think the point. I think we should iterate one more time. And then if still it keeps showing it, I think our load is slightly up those among these two members, and we need to group it as for practical standpoint. Don't have to differentiate those because those condition is almost identical. So this case scenario, the structural engineer, we need to group it. So we better use the same size here. Yeah, you're right. There is something. Somehow they chose 21. On the south side, similar. They're all same. West side,
Well,
east side.
well, no, the last beam
So
on
so this
the lower right is different. The lower right, 21 to 21. So should we just make them all 24 by
oh
55s?
oh yeah, yeah, 24 by 55 this case. But I think I have to point out one more time. Current geometry is not perfect. I mean, in terms of that, it's still acceptable, but geometrically, not every single beam is identical. Maybe can because I point out the column location slightly off here, there, maybe a few millimeter, a few inches, even half inches. Graphically, visually, we cannot recognize it. But when you zoom in further in, you maybe find out those beam spacing or column location slightly off. So identical is not identical. That may cause some bending moment value is just slightly off here there, but still that's something acceptable as a structural engineer. We have some structure sense, but something like this, same size, small size, but you maybe have to point out, oh, how can ETAPS choose small beam size but require more stiff stud? Look at this. It makes sense. Same moment that 24 by 55 will need a less shear stud, but somehow they choose 21. So this case, I'm gonna explain one last goal. So I think tutorial explain since you as a structural engineer, you wanna use this in the same mostly same condition. You're gonna group it. So you're gonna fall. Uh, this is spandrel beam north south, right? And then gonna assign this one. Let's say so this kind of great features because you eventually um, need a lot for steel is design. Spandrel beam east west. So I'm just assigned as group. When you run it, here there is a select design group. So you could just use this part of group. So what does ETAPS do internally? They just review it. They just only select one size for all this each group. So if we have two different cases, I think they just choose one size for each uh, assigned group. So let's see how ETAPS can give us the output. So Ispandero north and south. So you see that? So those they just give us the one single size, right? Because even though we have total 12 different spandrel beams. Some of them are identical, some of them ETAPS choose 21 by 55. But since we group it, they just choose it the one size for this group. Same as the spandrel beam on the west and south side, west and east side. Does it make sense? So this is part of a group. You don't first run, you maybe without group, you run it and find out total design and then just verify that whether it makes sense. But in practical standpoint, we don't use all different size. This condition is pretty similar. So we just group it and then choose one size for each group. So I think so today's class, I think this is good enough. I see generally looks fine. Interior bay 40 feet span, 18. But only last one, interior beam and girder. Especially interior beam, the beams we have a camber, 1.25 inches, right? This is typically repetitive elements. Camber is cost effective. Girder sometimes we do too. But girder is a 30 feet span. I think that's why TEPS doesn't said no camber needed. But look at the spandrel beam. I think this is also criteria. Spandrel beams, all faces, typically we don't use camber because the camber is kind of creates some flatness, levelness issue, and also in conjunction with the facade element, bottom wall. So typically, camber we use for interior beam and girder, not spandrel beams. I think I explained that this camber also we don't use at the moment frame and the brace frame beams. But this case is since we don't have it, just try to remind you guys, spandrel beam here, ETAPS design doesn't show the camber, which is good. So if ETAPS show the camber, right, in their design, we need to maybe reassign maybe for this let's say spandrel beam and criteria, maybe you could just turn off, what is that? Turn off the camber. Oh, not here. Or if you find that spandrel beam as a camber, you maybe scale up or size up. So you have to typical practice. We don't use. We have to use the beam with no camber for spandrel beams. So with that, I think we conclude today's exercise. I'm gonna just finally run it. The design check. 19, I have to run it one more time and I send it over to you.
Thank you so much, Professor.
All right. I think next couple, maybe 2 weeks, it's more fun. Listen, because this is important, as I actually always focus. Because before we copy, replicate, I think we should really get this model, floor framing model done and optimize, then replicate. And then we're gonna move on to lateral system because obviously all the steel tonnage is matter. Last one, let me just check and then feature. So everything's okay. So later, maybe next week and next Thursday, I'm gonna show you. So we're gonna typically bring it, split out all the material tonnages, the steel tonnages. From these features generally, and material, and I'll show you later. And we divide by total area of the plate, so that we could calculate the steel quantities, whether your steel framing is something optimized or over design. I think I mentioned that typically we are expecting for framing steel tonnage about between 4 and 5 pounds per square foot. Doesn't include the column, only just beam and girder. All right.
Okay, that's it. Thank
Okay,
you.
let's wrap it up. I'll send this PDF, but don't just look at opening. Just I think you could just still practice based on your previous model, and then try to learn. You could fix it as much as possible, right? And then just compare with this the ETAPS model. So I think you should be build your own kind of skills. All right.
Yeah. Oh, I also had one more question. I'm sorry.
Yeah.
Can you
Yeah.
show the turn on the openings for a second?
I think okay. Maybe I can explain that. That's a little more. Okay, since
So-
I don't. Yeah.
So
Since
is it supposed to be opening on like on the wall as well, or is it always supposed to be individual sections?
what do you mean individual?
So you see how I'm showing that the
Oh,
wall.
like this? Oh, like this? Okay. This is not okay. Two things. Since this is just for I think helping us. Current we don't draw the slab inside, right? So this wall, we call you see the opening elements. This doesn't do anything. You could just delete it and just leave it like this.
Okay.
Just give you the idea. Since we don't have a slab elements, right? Draw the open. You don't need to draw the opening elements. But if you want to, let's say, consider some opening on slab, if you have to select it, if you assign as opening elements, let's say opening type. Oh, maybe externally select that. Select only this. Assign shell. Assign only this small piece, right? So ETAPS is smart enough. Don't know that which one is superseded. So if we have a two area object, now it's object. One is a slab element, and the other one we assign as an opening. They recognize it, so they just kind of make a cookie cut. So subtract the area for this opening. But here, since you don't draw the slab, you don't have to draw this open element, right?
Okay.
Opening element.
Got it. Okay. And then
so it's yeah.
Are we?
I don't have to save it.
I know you mentioned the divider beams. Are we going to add that now or later?
No. In this one, try to avoid any miscellaneous element.
Okay.
But that is kind of I will show you that the structural drawing, construction drawing set. Usually you can find out, but those are not primary elements. We should not include. But since I've explained that major this corridor, slab, and beams is relatively heavy weights, right? Right. So we should actually, I just put that in here for load takedown. Otherwise, we miss the load. I know that we should actually also draw that some slab for that to cover that stairs, because typically stair will be made out of either steel, also concrete. But here, just assume this is steel, but we should somehow add some weight. But for now, for simplicity, so I don't draw that slab. No, for the stairs. So you don't have to also draw the stairs because they're complex, but you can maybe add some area for slab stair weight calculation.
Okay. Perfect. Thank you so much, Professor.
We are focusing outside. All right.
Okay.
So I'm gonna send over to you and see you on Thursday. All right.
Yeah. See you on Thursday. Thank you.
Okay.
Thanks so much for your time.
Have a
I
good day.
appreciate it.
All
All right. Bye.
Bye.